More types of forces. So last day, we looked at an awful lot, but in lesson 3, we looked at 2 types of forces, gravity and the normal force. By the way, both of those technically not forces. I think I told you last day, a lot of what I'm teaching you is wrong if we dive down. I told you there were 4 fundamental forces. There was the strong force, that's what holds the nucleus together. There's the weak force, that's what explains radioactivity. There's electromagnetism, that explains, surprise, surprise, electricity and magnetism. And then I said there was gravity as the 4th force. That technically isn't true. If you talk to anybody who's a modern physicist, Einstein explained gravity with a theory called general relativity as not a force. He was able to actually explain it as a curvature of space-time. We're doing what's called Newtonian physics, named after Sir Isaac Newton. And so gravity is the 4th force. I'm going to say to you, I'm lying technically. But then I said, yeah, we're going to have normal force, and later I'm going to look at friction. We already talked about tension. These are fictitious forces. They're combinations of those 4 fundamental forces, but they make the math easier, Fatima, so we'll pretend they exist. Okay. Air resistance. Finally going to talk about it a bit more. Air resistance is the force of air molecules, which do have mass, bumping into an object that's moving through the air. The key idea is the force of air resistance always has a direction opposite to the motion of the object. If you're moving up, which way is air resistance? Down. If you're moving forward, which way is air resistance? Backwards. If you're moving down, which way is air resistance? Up. Okay? The real challenge with air resistance is it's a variable force. As you speed up, with your hand out of the window, what happens to the force of air resistance? Bigger, smaller, or stays the same? Yeah, as you speed up, it gets bigger. It's a changing force, and since it's a changing force, what that really means is it's a changing acceleration, because F equals ma, and I told you way back when, we can't deal with a changing acceleration because we need calculus. So we'll look at it in snapshots at brief moments, but most of the time we'll ignore air resistance. The other thing air resistance depends on is your cross-sectional area. You may have noticed that if you stick your hand out like this, with it parallel to the ground, not much air resistance. In fact, you may have done the little flying game with your hand where you can also, by the way, don't do this when you're the driver. I should probably say that, but if you're the passenger and it's safe, it's good physics doing that. So it depends on your cross-sectional area. That's why a parachute saved my life when I jumped out of an airplane. I mentioned I jumped out of an airplane. And it depends on your velocity. So example 1 says, draw force diagrams for each of the following. A ball being thrown while it's in my hand, a rising ball, and a falling ball. Look up. Situation A is while the ball is in my hand before I let it go. Situation B is on the way up, and situation C is right there on the way down. Got it? You know what? I was going to say we can draw a free body diagram. Did they give me a picture? I'm going to label the picture, I think. So technically that's not a free body diagram. I'm supposed to represent the mass with a dot, but you're going to find if they give me a picture, I often just label the picture. So while I'm throwing the ball, what are the forces acting on it? Get the obvious one. What else? Is there another force? There must be. How do I know? Which way is the ball accelerating while it's in my hand? Which way must there be a bigger unbalanced arrow pointing? Gotta be. I'll exaggerate it. What force is that? I don't know. It's my, you know what? I think technically it's F hand. You could call it a normal force and treat my hand as a surface, but the throw. And I know, but I do know it has to be bigger. If it wasn't bigger than mg, look up. Here's an example of me applying an upwards force that isn't bigger than mg. What do you notice happened at the very, very end of my upwards force? The ball didn't keep going. For me to get the ball going, the force has to be bigger than, the upwards force has to be bigger than mg so that it continues to accelerate. Okay. B, while it's in the air, On the way up, what are the forces acting on it? Get the obvious one. What else? Well, in B, in the brackets, it says include air resistance. Okay. Which way would air resistance be pointing? It's a little awkward to draw it on the same arrow, so I'll put it right beside, and I'll call it F air. Okay. C, what are the forces acting on it? Get the obvious one. Gravity down. And again, we said last day you can write Fg, but we said the equation for gravity was mg. And so you're going to notice a lot of the time I just put the equation mg to have it. What else in part C? Yeah. Which way? Yeah. Wait a minute, Mr. Duick. This bugs me. How can the ball, example 2, how can the ball be rising if all the forces on it are acting downwards? Are we wrong? So the answer is it can be. How? Nope. Good thought, though. This goes back to, oh, go ahead, Max, because this goes back to a comment you made last day that I jumped on right away. Nope. Newton's laws don't tell us which way something moves. They only tell us which way something will, looking for a word that starts with the letter A, only tells us which way it will accelerate. And this is why last day when you started to give an explanation and you used the word moves, I jumped on you right away and I said, accelerates, but doesn't tell us which way it moves. So here's my question. Which way is the ball moving? Starts with letter U. Is it speeding up or slowing down in part B? So which way is it accelerating in part B? Down. Look at my free body diagram. Can that accelerate down? Absolutely. I have two unbalanced forces pointing down. That will accelerate down. We're not violating any laws of the universe. Okay? So Newton's laws tell us A, not V. And if I look at that and analyze it, clearly it's accelerating down, and that's what my free body diagram shows. Two forces pointing down. Newton's first says, yeah, it will be accelerating down. Doesn't mean I'll be traveling down. Now, it's going to slow down, slow down, slow down, and we know enough to know eventually at the top it's going to come to a stop, and then it will start traveling in the same direction as the acceleration, and that's usually true. Usually, eventually, you end up traveling in the same direction as your acceleration, but not at the beginning. Let's look at C, this one here. Example 3 says, if the falling ball in example C is speeding up, write a net force equation. If we're speeding up, which way are we accelerating in part C? If we're speeding up, which way are we accelerating in part C? I think you're right, Annika. Yep. So if we're speeding up, which way are we accelerating in part C? In this diagram here, down. So who's winning? More specific in my free body diagram. Yes? Yeah. Okay, so this is what for those of you that were away last day, I introduced a tug of war analogy. Don't write this down. We said that we're going to analyze our force equations by going winner minus loser equals MA. Okay? By the way, in B, who's winning? First of all, motion is not a force. Stop doing that. Which way are we accelerating? In B, so which way is the winning direction? Same answer. Which way is the winning direction? Same answer. Down. two winners. If I was writing the equation for B, don't write this down, it would be the force of gravity plus the force of air equals ma. It would be winner plus winner, no losers. This is like elementary school sports day. Everyone's a winner, no losers. Everyone gets a ribbon. So you don't always have to have a minus in your equation. Oh, and if everything is pointing in the winning direction, no worries. It'll still work. This method that I'm giving you, you'll find is incredibly versatile. In Physics 12, you will not learn anything besides winner minus loser equals ma. You'll just look at more complicated two-dimensional situations. So back to here. What direction did you say is winning, Annika? Looking for where this starts with the letter D. So which force did you say was winning, Aiden? Minus, which is the losing force pointing upwards, F air. And what does winner minus loser always equal? ma. If you told me the acceleration, I could find air resistance, or if you told me air resistance, I could find the acceleration. Hey, let's do one with numbers. Example 4. A 90-kilogram parachutist free falls for a time and then opens a parachute. His new upwards acceleration, why would his acceleration be upwards? When he opens the parachute, what direction is he moving? Down. But when he opens the parachute, does he speed up or slow down? So if you're moving down, but you're slowing down, which way are you accelerating? Which way is the nut unbalanced force pointing? Upwards. Which way is my winner going to be? Same answer. Upwards. Okay. It wants a free body diagram. Let's do the free body diagram right here. Let's put a little part A. What are the forces acting on this parachutist? Get the obvious one. Yep. Go systematically. When he pulls his parachute, what direction does he accelerate? Up. Doesn't mean he's moving up. He's still moving down, but slowing down. So which way am I going to have a bigger arrow pointing? I'll exaggerate it so it catches my eye. What force is that? Your hint is, we just talked about it in the ball question. Air resistance. B says, write a force equation. Okay. Peniel, which arrow is bigger in my free body diagram? Which arrow is bigger in my free body diagram? Please tell me you drew air bigger, yes? Which arrow is bigger? I'm going to ask you the same question. I want the same answer. I'm just going to phrase it differently. Which force is winning? I want the same answer. What did you just say? I'm going to ask you the same question. I want the same answer. I'm just going to phrase it differently. Which force is winning? Yes. Okay. Which force is losing? What does winner minus loser always equal? Okay. There's my equation. By the way, if I was speeding up, then air resistance would be smaller, and it would be mg minus F air equals ma. Okay. What's C want me to find? Air resistance. It wants me to get F air by itself. Is this a swappy dance one? Is there a minus in front of the F air? Is there a minus in front of the F air? No. Is there a minus in front of the F air? No. Is there a minus in front of the F air? Okay. So this is not a swappy dance one. How would I get the F air by itself? I'll move the mg over. How would I do that? I know you're going to the punchline, but I got to make sure I walk people through it, right? So to show my work, I might do that. I'd figure out what you were getting at. And my new equation then for part C is going to be F air equals mg plus ma, or ma plus mg, because when you're adding, the order doesn't matter. 5 plus 6 is 6 plus 5. Okay. Now they want me to crunch the numbers. M, what's the mass? 90. G, 9.8, not negative in this unit. I took care of the negative with my winner minus loser. M, 90. What's A? I'm guessing the question told me somewhere, I hope. And hopefully you're at the stage where you looked for a meters per second squared and then found the number rather than looked for a number and then looked at the units. I went, oh, meters per second squared. What is it? 1.5. So this is going to be 90 times 9.8 plus 90 times 1.5. Can I do that in my head? Maybe. It's going to be 90 times 11.3, so it's going to be 990 plus 270. Is it going to be 1,160? Is it 1160 or am I way off? Am I wrong? I'm wrong? I forgot to carry a 1 somewhere. What did I do wrong, Mr. Duick? I hate having to fire up my calculator. 1,017. I was off by a decimal. Way off. Wow. Now, look up for a second. Don't write this down. This is just to help you understand the physics of free fall. So this equation here is what I experienced when I opened my parachute. As I slow down, what happens to my acceleration? It gets smaller and, sorry, let me say it this way. How would I want to say this? Sure. As I decelerate, my speed slows down. What happens to the force of air resistance as you slow down? It gets bigger or it gets smaller. What have you noticed when you stick your hand out of the moving car? As you slow down, the force of air resistance? Smaller. So as my parachute slows me down, this gets smaller and smaller and smaller and smaller. Eventually, my equation becomes gravity equals ma. Well, no, that's actually when I jumped out of an airplane. What I would really like is to have a big enough air resistance so that eventually my acceleration gets smaller and smaller and smaller, and eventually air resistance cancels out gravity. That's terminal velocity. That's terminal velocity. I think I have a short video on the physics of skydiving, do I not? Oh, yes, I do. So the reason air resistance is so tricky, Dan Veer, is it's not a constant value. The force gets larger as speed increases. A falling object will eventually reach a point where the force of air resistance equals the weight of an object, and there it will hold a steady speed that we call terminal velocity. I don't think I'm going to test you on that term, but it's kind of a nice physics term to have in your back pocket. Put your pencils down, look up. I changed this, so can you cross out the question that you have? Cross out, I think there's a paragraph there about doing a graph or something like that. Just cross that paragraph out. Turn the flame over, Max. There you go. Okay? And once you've crossed it out, can you write down, we don't always need to do a free body diagram. Students kind of go free body diagram loopy. And then can you copy out example 5, please? So I changed this in your notes. And example 5 says, I think I can make it a little bit larger. A 1,200 kilogram car accelerates from rest to a speed of 33 meters per second in 8.5 seconds. What is the net force on the car from the tires? A 1,200 kilogram car accelerates from rest to a speed of 33 meters per second in 8.5 seconds. What is the net force on the car from the tires? And then once you've written that down, key idea. When the question asks for the net force, we can go straight to, and there's a blank. Once you're done copying all that out, kind of look up, and as you make eye contact with me, then I'll know I can move on. Take your time. No rush. Don't rush. I'm a slow writer. It's why I type everything. One of my pet peeves in movies is when the scene calls for somebody to be writing a letter and they're either reading it out loud as they write or they're thinking it as they write. And apparently they can handwrite at the same speed that you and I talk. That always drives me crazy because you see them, they're not writing that letter. They're just scribbling on the page and they're just not showing me the page. Yeah. Anyways. Maybe you are. I'm not one of those. Okay. You're still bitter about that, are you? Okay. I know you do, but what am I? The trigger phrase here, wrong playground insult, right? Can you underline the phrase? That's a trigger phrase. If you see in the question the phrase net force, you can go straight to MA. And the reason is, it's actually not F equals MA, it's F net equals MA. So this question here says to me, what is the net force? My first thing, I wouldn't worry about a free body diagram. What I've done is I've summed up all the forces for you in my free body diagram, and I've jumped straight to the punchline. So Ethan, this wants me to find the net force. I would look at the question and I would say, okay, F equals MA, F net equals MA. Did they give me a mass? Did they give me a mass in the question? Yeah. Did they give me an acceleration? Okay, so first of all, I'm looking for a two-letter word that starts with the letter N. Did they give me an acceleration? No. But you're right, I can calculate it. So even though this question says, find the net force, what's it really asking me to find? I'm going to calculate an acceleration. That's what I'm going to spend most of my time doing. So I'll make a little note. I need to find the acceleration to answer this question. Typically what I do, if it's the question, I would say F equals question mark. If it's something I need to find, I put a blank there. That's my way of saying to myself, that's not the real answer yet. I'm not done, but that's a blank I need to fill in. That's my organized but lazy system. What else do I know? Yeah? So let's go kind of in order in the question. Okay. So what could I use to find the acceleration? Yeah. Can you get the A by itself, please? Oh, you are. I'm sorry. I stand corrected. You didn't say A equals. Yeah, VF minus VI. So it's going to be 33 minus 0 divided by 8.5. I don't think the minus 0 is going to make a difference, so I'm just going to go 33 divided by 8.5. I get a yucky decimal, 3.88 something. I'm going to write 3.88. Kiana, is that the number that I'm going to use? Or am I going to use my answer button? Okay. Then my high-tech system, I just draw an arrow pointing there. That tells me that's where I plugged it into. Come up with your own system. This is just mine because I'm lazy but organized. And I'll get this. The net force is equal to 1,200. I'll write 3.88, but I'm going to use my answer button. And I get 4,660 newtons. Yep. So Nicholas, do I always have to do a free body diagram? If it says net force, that's their shortcut saying to me, look, I've done the winner minus loser, and this is what happened. And typically, by the way, if they give you the information to find an acceleration, what we were typically finding in the last unit was the net acceleration anyways, so it worked. Okay. Now, here's the nice thing. What that also means is during this unit, I'll still be reviewing a lot of the kinematic stuff so your skills won't get rusty, which is kind of nice. What's your homework? Number 1 is good. You know what? I'll tell you what to cross out. You can cross out number 8. And I think that's it. But I'm not doing anything more with this class. I'm going to hit pause, okay? But I have a short video. Put your pencils down.